Dear friends, today what we are going to discuss about is the definitions of IoT, characteristics of IoT, physical design of IoT, logical design of IoT, and IoT protocols. So IoT, a dynamic global network infrastructure with self-configuring capabilities based on standard and interoperable communication protocols where physical and virtual things have identities, physical attributes, and virtual personalities and use intelligent interfaces and are seamlessly integrated into the information network. Often communicate data associated with users and their environment. Characteristics of IoT: dynamic and self-adapting, self-configuring, interoperable communication protocols, unique identity integrated into information network. IoT devices and systems may have the capability to dynamically adapt with the changing context and take actions based on their operating conditions. Example, surveillance camera can adapt their modes based on whether it is a day or night. So IoT devices may have self-configuring capability, allowing a large number of devices to work together to provide certain functionality. IoT devices may support a number of interoperable communication protocols and can communicate with other devices and also with the infrastructure. Each IoT device has a unique identity and a unique identifier, IP address. IoT systems may have intelligent interfaces which adapt based on the context, allow communications with users and their environmental context. IoT devices are usually integrated into the information network that allows them to communicate, to exchange data with other devices and systems. The physical design of IoT, the thing in an IoT usually refers to IoT devices which have unique identities and can perform remote sensing, actuating, and monitoring capabilities. IoT devices can exchange data with other connected devices and applications. It collects data from other devices and processes the data locally, sending the data to a centralized servers or cloud-based application backends for processing the data. Perform some tasks locally and other tasks within the IoT infrastructure based on temporal and facial constraints. So this is the general black diagram of an IoT device. An IoT device may consist of several interfaces for connections to other devices, both wired and wireless networks. The connectivity has USB host, RJ45 Ethernet cables, then central processing unit, then audio video interfaces, then memory interfaces, graphical processing unit, then storage devices, and IO interfaces, sensors and actuators. The IoT protocols has various layers. The top layer is an application layer, then a transport layer, network layer, and link layer. The link layer protocols determine how the data is physically sent over the networks. Physical layer medium. The link layer determines how packets are coded and signaled by the hardware device over the medium to which the host is attached. 802.3 Ethernet standard. The 802.3 is a communication protocol, collection of wired Ethernet standards for a link layer. The shared medium carries the communication for all devices on the network. 802.11 Wi-Fi. IEEE 802.3 is a collection of wireless local area network. For example, 802.11a operate in the 5 GHz band, and 802.11b and 802.11g operate in the 2.4 GHz band. 802.11ac operates in the 5 GHz band. IEEE 802.16 is a collection of wireless broadband and standards, including extensive descriptions for the link layer, also called WiMAX. The WiMAX standard provides a data rate from 1.5 megabits per second to 1 gigabits per second. IEEE 802.15.4 is a collection of standard for low-rate wireless personal area network. These standards form the basis of specifications for higher-level communication ZigBee. The low-rate wireless personal area network standards provide data rate from 40 kilobits per second. These standards provide low-cost and low-speed communications for power-constrained devices. The network layer are responsible for sending of IP datagrams from the source network to the destination network. This layer performs the host addressing and packet routing. The datagrams contains a source and destination address which are used to route them from source to the destination node. Host identification is done using the hierarchy IP addressing schemes such as IP version 4 or IP version 6. IP version 4 is the most deployed internet protocol that is used to identify the device is on network using a hierarchy lattice schemes. It uses 32-bit addressing scheme. IP version 6 is the newest version of Internet Protocol and successor to IP version 4. So IP version 6 uses 128-bit addressing schemes. The IP version 6 over low power wireless personal area networks brings IP protocol to the low power device which have limited processing capability. It operates in the 2.4 GHz frequency range and provides a data rate of 50 kilobits per second. The transport layer provides end-to-end transfer capability independent of underlying network. The message transfer capability can be set up on connections either using handshake or without handshake acknowledgements. So transport layer provides functions such as error control, segmentation, flow control, and congestion control. The transmission control protocol is the most widely used transport layer protocol that is used by the web browsers along with HTTP, HTTPS application layer protocols, email programs, and file transfer protocol. So TCP is a connection-oriented and stateful protocol, while IP deals with sending packets. TCP ensures reliable transmission of packets in order. TCP also provides error detection capability so that duplicate packets can be discarded and low packets are retransmitted. It also deals with flow control issues. UDP is a connectionless protocol. UDP is a transaction-oriented and stateless protocol. UDP doesn't provide guaranteed delivery, ordering of messages, and duplicate eliminations. The last layer is the application layer. The application layer protocol defines how the application interface with the lower layer protocols to send the data over the network. Data are typically in files is encoded by the application layer protocol and encapsulated in the transport layer protocol. Application layer protocol enable process to process connections using ports. The application layer protocols are hypertext transfer protocol, which is used to transfer web pages, constrained application protocol, web sockets, extensible messaging and presence protocol, XMPP, and advanced message queuing protocols, AMQP. Thank you.